Hey, so today we're going to be diving into the strange anatomy and geometry of a black hole. Not just what they are, but their actual structure. Most people think of black holes as just pitch black spheres that eat everything, and while that's kind of true, it's also not even close. So in this video, we're going to break down the actual shape of a black hole. Not just the fact that it's a sphere, but all the crazy parts that make it what it is. Like the accretion disk, the photon ring, the event horizon, and even weird stuff like the Schwarzschild radius. But why does any of this even matter? It matters because the shape tells us how something works and why it's so terrifyingly cool. Alright, but first a quick refresher on what a black hole is. A black hole forms when a supermassive star dies. I'm talking about a star so huge that it just collapses under its own gravity. The core gets crushed into a single point, something so dense that the gravitational pull is so strong that it exceeds the speed of light, hence why it's a black hole. This is basically just a region of space where gravity has just hit its cheat codes. And the weird part is that it's not even really like a hole. It's an object, a region, and a thing. And once you get too close to it, the normal rules of the universe just sort of melt away. And this is the whole point that this video exists at all. The fact that something so powerful and extreme can have any shape or part to it at all is just mind-bogglingly crazy. So now the actual anatomy and the actual geometry of a black hole. And firstly, yeah, black holes are just spheres. You know, it's nothing wild at first glance, it's just a sphere. But it's a lot deeper than just a sphere. You know, this ain't just any sphere. This is a sphere that warps space, it warps time, and it just eats everything around it. You get too close to this sphere, and your concept of time, space, and even distance are just twisted and stretched that math can't even save you. And that's why something as simple as just a sphere becomes much more terrifying. So the first thing you'd probably notice when looking at a black hole isn't probably the actual black hole itself, but the accretion disk around it. It's this glowing ring of gas and dust, and sometimes entire stars even being consumed into it. And this thing gets like ridiculously hot from all the friction and heat in it. These things can sometimes get so hot and so bright that they outshine entire galaxies, which is why quasars exist at all. And not every black hole has one though. They only occur when something is being destroyed and it's in the process of sort of orbiting the black hole. And sometimes it's just the remnants of stars endlessly spinning around them, just never really being totally consumed by the black hole, just perpetually orbiting it. And then right near the edge of a black hole is this thin little ring called the photon ring. This is like a thin little region where light doesn't really get consumed by the black hole, but the gravity's too strong for the light to escape either. So this light, this thin little band of light, just sort of won't get consumed and it can't escape either. So it's just endlessly spinning around the black hole at the speed of light. It's basically the last glimpse of anything before it just turns black. And then we hit the event horizon. This is the infamous point of no return. This isn't just some indomitable barrier wall. It's just a boundary. Once something crosses the event horizon, it's over. And if light can't escape, nothing else can possibly escape a black hole once you're past the event horizon. The event horizon is sort of just the circumference of the black hole. It is the black hole. It's not made of stuff like any object. It's just gravity, like really strong gravity. Now we're getting on to some of the more mathematical things with the Schwarzschild radius. The Schwarzschild radius is the distance from the center of a black hole to the event horizon. It's like the radius on any other sphere or circle. This is used to refer to the physical aspect of the black hole, like anything in the black hole from the center to the event horizon. But it also can be used to refer to the mathematical aspect of any physical object. So anything can become a black hole if you squeeze it down tight enough and small enough. This is because in order to make something's gravity be strong enough to where it exceeds the speed of light, it needs to be like really dense, which is why like even the Earth can technically or theoretically become a black hole if it was crushed down to the size of a marble. This is because the density of the entire Earth packed down to the size of a marble, the gravity of that marble would exceed the speed of light, thus it would become a black hole. The Schwarzschild radius is the size something needs to be in order to collapse into a black hole, given the mass of that object. So for the most part, it isn't really like a physical part of the black hole. It is the radius, but it's more used for the mathematical aspects of other objects. It's key to how black holes form at all, and it's a really important aspect to why black holes can even form from a collapsing star at all. And now finally, the singularity. The singularity is the center and the heart of a black hole. This is a really weird region because this is where physics basically just stops playing by the rules. And the weird part is that we don't actually know what's going on in the singularity of a black hole. This could be anything. It could be an infinitely dense point, it could be a wormhole, it could be a tear in space and time. It's inside of the event horizon, and since nothing can escape a black hole, we just have no idea what it is. Even our best equations and mathematical formulas, they just break down when we try to understand how this thing even works at all. It's already mind-boggling that an object in space can have a gravity so strong that it becomes totally black and it eats all the light. But to imagine the center of that thing is even more dense, it makes no sense. And that's why singularity is so mysterious and confusing, and why it's basically just on a whole other level of these other parts of the black hole. And so yeah, people might say a black hole is just some sphere floating in space and eating everything. And while that's technically true, it's a lot more complex and convoluted than just it goes around and it eats everything. It's got structure, it's got layers, it's got boundaries, and it's even got regions where math and physics just stop working entirely. Black holes, they aren't just space vacuums. They're entire systems that defy logic, understanding, and reason. And to this day, they're one of the clearest reminders that the universe doesn't really have to make sense in order for it to be real. Anyways, thanks for watching. This is just my second video, and it's only the beginning. And if you enjoyed, please like and subscribe. And I've got a lot more topics coming up, so stay tuned, and peace.